On black holes. Black holes as presented by modern physics do not exist. The black hole singularity is a mathematical concept of a super-dense star of infinitely small size and of infinite density. The singularity comes about by stellar collapse under gravity, where there is no known physics beyond electron and neutron degeneracy pressure to prevent the total collapse to a singularity, but nature knows a way, hadron degeneracy pressure. Large stars, with cores greater than 1.4 solar masses, once they have run out of enough fuel, collapse to hadron stars of various physical sizes, small super-dense stars, but not singularities. So what exactly are hadrons? Hadrons are the more massive particles in the atomic world. Hadrons are massive particles made from quarks and antiquarks. One such very common and stable example is the proton, which is made from 3 quarks. Another example is the neutron, which is also made up of 3 quarks. There are more massive versions of these two common particles. They are more massive because they contain more energy, mass energy. More massive particles, because they carry more energy, have a higher frequency, and since they have a higher frequency they are of shorter wavelength. This means they are smaller and more dense. The enormous pressures inside a collapsing star causes the collapse of atoms, made of protons and electrons, to neutrons, producing a neutron star. This resistance to collapse is called electron degeneracy pressure. Beyond this limit is theoretically neutron degeneracy pressure, where neutrons are being spushed into each other, but in fact, if there is enough gravitational collapse, this super-dense star of neutrons will be squeezed into smaller and more massive hadrons. This will not be a linear collapse to smaller and heavier hadrons within the star, but will occur in quantum jumps. Each quantum collapse will require greater and greater quantum gravitational forces to overcome quantum hadron degeneracy pressure, and therefore there will not be total collapse to a singularity. Heavier, that is, more energetic versions of the neutron can only exist in quantum masses and sizes. Therefore, black holes are quantum-sized hadron stars composed of quantum-sized hadrons. Since there is a limit to the size of stars, the biggest being 120 solar masses, there will be a limit to the mass and size of hadron stars created from the collapse of their massive cores. No star exists that is massive enough to produce a black hole singularity. Bernard Paul Badham. The Enigma of Gravity.